this talk right now, what's going to happen is synchronous. I say or show something, you immediately hear it and see it. You can raise your hand in the middle and ask me a question as soon as you have it. And we can celebrate the simplicity of synchronous execution. Or you can take the more async route by trying to remember all the questions you've had until the end. At which point, you might need to bring back all the relevant context. Your questions might have changed a little bit. Maybe something else comes up and you're no longer interested in asking that question. So much uncertainty. Maybe you come up with a question tomorrow or a few days later, at which point you have to track me down on social media. You can probably also just stay for a little bit after this talk. And I wrote that bit in here, but at that point I did not know that I was going to be placed at the very last slot of Friday, because as soon as this talk ends, I'm running to the airport. My flight is in like about 3 hours from now. So yeah, definitely catch me on social media after this if you have any chatter. Speaking of which, hi, I'm Dev and I'm a dev. Sorry.
Just wondering where your flight is out of.
Cleveland?
Okay.
Yeah.
Drive.
It's like a 45-minute drive, and I've heard that it's not too long of a TSA wait line, so I should be okay. But no like cutting it close. But as far as social media is concerned, I live basically on Twitter. I'm eternally online. I'm a software engineer at Smart Data. It's a consulting company based here in Ohio, Dayton, Ohio, to be specific. I contribute to open source a little bit. I'm a core team member of SolidJS. How many of you are familiar with SolidJS? Okay, that's more than what I was hoping, so good to know. It's kind of like React, but I'm going to say better, but obviously I'm not. And I contribute to TanStack Start, which is the full stack framework built by the same authors of TanStack Wiki, TanStack Table, and some of those open source frameworks that you might have been using. If you like my talk today, please check out some of my YouTube content. I make videos about web development, about software architecture, programming in general, and a lot of stuff like that. So this talk is about building asynchronous UIs without hassle. I'm here today to convince you of 3 things. Synchronous state is simple. Asynchronous state is complex. And we have finally found a way to make asynchronous state relatively simple. So that's kind of the TLDR of the talk today. Synchronous state has been easy since frameworks like React, Vue, and Angular make them easy for us. They allow us to model our applications as state and UI as a synchronous derivation of that state. Sure, there's still async because event handlers in the DOM are async, but as long as any async event can be represented as a new state in our application, we can very easily handle it. So we define all the different states that our applications can be in. We define how each state is reflected in the UI, and we simply move between these states as async events happen. This is a fantastic programming model to write highly dynamic applications and highly responsive applications in, really. It definitely wasn't all easy. Having to represent every state in our app can be a bit tedious and complex, so we had to come up with some patterns to help us manage the complexity of this state. This gave rise to state management solutions like Redux, the maintainer of this library sitting right there. Redux gives us this reducer pattern that defines how the state can be mutated right there with the state itself. Or MobX that adds a layer of derived values and some fine-grained reactivity. Or Xstate that introduces finite state machines with specific state transitions. Wow, that's a tricky thing to say. That can happen in any one state. Now, initially we used these frameworks like React and Vue to build little embedded widgets or interactivity islands within our websites. But as we started building complete applications with these frameworks, especially with the introduction of client-side routing, one of the biggest challenges was doing asynchronous things like fetching some data, or fetching some code, or triggering actions like post or delete requests. And this might hint at why that's the case, why it's more complicated. This code here is the simplest way to fetch some data from an async source, like a server, that also covers intermediate states and handles race conditions. It doesn't even have any features for caching and revalidation. This is the minimum amount of mental overhead that needs to happen when you deal with an asynchronous state within a fully synchronous system like React. This example isn't React, but it's actually going to look very familiar or very similar regardless of what framework you're using, whether it's Vue or whether it's Angular or anything else. Let me dig into why this case is so complicated and what makes this synchronous to asynchronous thing really difficult or causes this impedance mismatch. The code here is really not that super important. Here, we have a few states that our app can be in, A, B, C, and D. It's pretty straightforward. We can go from A to B to C. But let's say that D here is an asynchronous state. It means we can't exactly just switch from C to D, just like we can do with the others. There's an async operation, maybe a call to the server, that has to complete before D is available. Some time has to pass between C and D. We can't know exactly how long that's going to be. We have to assume that the user will notice it, and we also have to assume that this async operation might fail because of many reasons. So we inevitably have to create 2 additional states as well as a fork or a branch. For every state that requires an async operation to reach, we need at least 2 additional synchronous states, one to represent that it's not yet resolved and one to represent its failure. This complexity just keeps adding on to itself as we add more of these asynchronous states. Imagine that once we reach D, we can go to another async state, E. Now we have another one of these forks. This could be either another screen of the app, another page that needs some data, or maybe we could, or this could be a post request. Maybe we have D and E as separate operations, but combined on the same state, which means now we have something like this or something like this. I'm pretty sure that you have experienced these sort of cases, not just in the applications that you use quite frequently, but maybe in the applications that you build it as well. And this is not just a developer complexity problem, this is a user experience problem. If you have a page with 5 of these async operations that all need to settle, your users might experience 5 different loading states before they can see the content that they want to see. It's not great. But that's also not where the problems end. Managing these async tasks itself is a challenge because of this thing called race conditions. Here we have a normal non-race example where we first enter D, it resolves, and then at some point we transition to E, and then it resolves as well. Everything is fine here. The problems start coming up when we switch to E while D hasn't been resolved yet. Here there's 2 possibilities. The first is that D gets resolved before E, in which case we might show D for a little bit and then we show E. So the wrong state flickers in. The other possibility is that D resolves after E, in which case E flickers in for a bit, which is the correct state, but then we enter the wrong state and the app gets stuck there. What we actually want to do in these cases is somehow ignore or discard or clean up the results of D so that we don't have the app flicker in the wrong state, or worse, flicker in the correct state and then get stuck on the wrong state. Let's show what some of these look like. So I have an example here. I'm going to start mirroring here, and this is the application. It's kind of a minimal version of the conference schedule app that you might be using for Codemash or really any other conference. So when I refresh, we see the loading schedule page, loading schedule data, and we have 3 tabs here for 3 different days. We click on day 2, we show the loading indicator, and then we show the data. We go on day 3, once again, we show the loading state, and then we show the data. What happens when I click on day 2 and 1? We see the data for day 2 first, it flickers in, and then we see the data for day 1. Now this is just like some that race condition or that intermediate state problem on the first page. Let's hop into the session details page by clicking here. We see loading session page, loading session details, and you see just how many loading states are on this page. we see the speaker details here, the session details. We have a button for the bookmark. We can click here to toggle it. It also goes back to pending and then goes back to loading. And we have a login thing here. So let's also quickly go to login. I'm going to log in as an attendee. I was too lazy to come up with a whole login system. It's really just a demo anyways. Whoever says rolling your own auth is easy. So now here, we have a couple additional loading states now, one for this loading component and one for the data that this component needs. Once again, we can click a button here, everything disables, we see the loading indicator, and then we see the final state. So this might seem familiar, and this is certainly not a trivial demo or not a trivial application. It's not a hello world or to-do application, but this is still much simpler than most real-world applications that I have built. And I'm sure this is much simpler than most applications that you build on a daily basis. Let's look at what the code for this looks like. So I'm not using any libraries here. I'm just using React, vanilla React. I'm not even using routing. I have this makeshift in-memory router here, which we can be on the session details page, it can be on the home page or the login page. And then I have a piece of state here that stores the current state, the current route that I'm on. Then in here, I have our header. We have the main tag where we go through all the different routes that we can be in. So for the home page, I'm going to show the schedule. For session details, I have the session details component, and then of course I have the login component. Once again, please don't do this in any applications. Use a real router. I just wanted everything to be in front of us so that we can see what's going on. Now the schedule and the session details component is a little different from what you might usually do, because these components are lazily loaded. The code for these components is not there in the initial bundle. It's only going to be loaded when the user hits this page or when the user wants to see this page. Because one of the things you might want to do in single page applications is code split your different pages or different routes. Because you don't want all of your code to be shipped to the client at the very first render. You only want the code for the page that they're currently on. So for this, I have a hook here called use async data that makes a fetch or runs an asynchronous function. In this case, I have an artificial timeout, then I import this component dynamically, and then it's going to be returned here by the hook. If this component exists, we're going to render it with the props. If not, we show a placeholder. So we're already seeing that we need placeholders for our async sources. I also have a little thing here to store it once it's been loaded, so we don't need to asynchronously load this component every time we render it. We only need to do it once. And we do the same thing for session details. Now let's hop into this component and see what that looks like. So for the schedule component, I'm going to zoom in a bit more. Once again, we have a piece of state that shows which tab you're looking at, day 1, day 2, day 3, and we have tabs that we can switch between. Then once again, we use async data hook to get the schedule for our current tab or for our current day. It gives us back the sessions variable, which can be either an array of session or none. Same thing here, we fetch a list of all the speakers so that we can show the speaker's name, which can be speaker array or not. Pretty straightforward. And down here is where we start facing all the intermediate states once again. So if sessions array exists, we are going to render this. If not, once again, we have a placeholder. And for each session, we have a button. Yes, I use Tailwind here. I like Tailwind. If whatever your feelings are about Tailwind, you can express them to me after the talk. But we have a button for each session. When we click on that button, we route or we navigate to the session details page. Once again, please use a real routing library for this. And if the speaker's data has not been loaded yet, we show yet another placeholder, and we show this name of the speaker once it's loaded. We have the same thing, a similar thing going on the session details page, where we get the session ID, and we use that to fetch the session data. Then down here, we need to check if the session exists. And if it doesn't, we return null. And if the session exists, we fetch the details of the speaker for this current session. And we rely on the session information because that's where the speaker ID is. And then down here, we are going to check if the session has been bookmarked by the current user. Then we have an action. So along with use async data, we have a use async action as well. Now both of these two hooks have been custom made that I'm going to dig into as well. But most likely this is going to come from either a framework or a library like Query, which is going to manage a lot more async stuff for you. But here it's pretty straightforward. I can toggle the bookmark for this current session, and after that I can refetch the bookmark data, which is going to give me the latest information right here. So once again, loading placeholder if the session details are not there yet, and once they are, we have another placeholder for when the bookmark status is not yet complete or not yet fetched. And once that's done, we have a button here that shows the bookmark, and when you click on it, we toggle the bookmark. Straightforward. We show the session time, session description, and once again, if the speaker details are not there, show yet another loading placeholder, otherwise show the name and bio. Now down here, we are checking for what the role of the current user is. So for attendees, we show the attendee feedback widget, and for speakers, we show a different feedback widget. Again, the reason here is that different users might see different content or different components, and based on that, you want to load or you want to show different UI on your page. Again, I'm not going to dig deeper into this because I feel like until now you might get the point that for every async operation, we need to show a loading indicator. And so far, and in this demo, I haven't even placed any error UI, any error handling, because doing that will, at the very least, double the work that we have to do. Because for every async source, we have an error that we need to handle, and on top of that, error states have a little more work that you have to do because you need to give the user a way to retry or a way to go back to a different page, something like that. So you can imagine how much work, how much extra overhead, how much extra work that needs to be done here, and how many additional states that the user might have to go through. Okay, so intermediate states, you click on something, you have multiple intermediate states, and so on. That's the main problem that we have to deal with. All right. Now, there's actually yet another problem that happened in that demo that you can look at, which is that it's actually a little inefficient to do all those asynchronous things in a series. We have something called a cascading client-server waterfall, which is where the client makes multiple requests to the server in a sequence instead of getting everything in a single request at the same time, or making multiple requests in parallel to get all the data. But this problem actually deserves a whole separate talk. I gave that talk at StirTrack last year. It's up on YouTube. I might give it at a different conference at some point. But the TLDR for this problem is that there's a tug of war going on between hoisting your data requirements up into a separate system versus pulling them down in your UI components and co-locating them. You want to hoist them up for efficiency, like we see here, but you also want to co-locate them for better maintainability and scalability of your code base. What's that talk for a deeper dive into this? The reason why that's a separate talk, because the technology or the patterns that I'm going to talk about today don't really do anything to address this problem. It requires kind of a different solution. But just in case you're wondering that there's async stuff going on, one after the other, and it seems inefficient, this is one. Now the best way to talk about how React and Solid and some of these frameworks address the problems of intermediate states and race conditions is to introduce our good friend, delimited continuations. That's quite a word. How many of you know what that is? Okay, basically zero. How many of you know what try-catch or async await is? Okay, so you're all familiar with delimited continuations. You just didn't know. Let's quickly compare to how we did async stuff without promises. We have this data structure called a promise. And for every promise, we define a success and an error callback. Async await simplified this by giving us imperative access to the resolved value, and it made error handling optional in the sense that it hooked into the try-catch system. Try-catch gives us this way to model just the happy path for our code as long as we want to, and it allows us to arbitrarily choose when we want to handle the errors for a set of expressions by simply wrapping it with this try and catch statement. Now, I don't like everything about try-catch, and a lot of times I prefer more errors as values approach, but then I'm also forced to handle the error at every single step. That might sound familiar. And that's why it's really hard to deny that this try-catch and async await model, they're really simple and really intuitive because they allow us to model just the happy path. And that's kind of how this new async model works in modern frameworks. They eliminate the need for intermediary states for every single async thing, and instead they give us a model where any asynchronous state can simply be transitioned into just like a synchronous state. We are not forced to handle the loading or the error case, and we don't even need to handle a case where the value might be undefined. And let's see what that looks like. Error. All right. I am going to stop that. Let's hop on to a different branch. It's GCO, npm run dev. And now we're going to go back here. I'm going to refresh, and we're going to see a white screen for a little bit. And then we're going to see just the fully rendered page. No intermediate loading states. We click on day 2, day 3, no intermediate states. We're going to click on day 2, and we hop here. Now, the state transitions don't happen immediately. They don't happen synchronously because we are not working around the asynchronous fetching. There's still some time. So I click, wait, and then we switch. Same thing here. I click on this, we're waiting. There's no intermediate states, and then the page just shows up with the fully rendered, all the content there. No intermediate states. Let's log in and see what it looks like with the feedback widget. I'm going to log in as an attendee. Once again, we see the fully rendered page here. I click, we're waiting. We have to wait a little longer because now there's more things that are loading, but then we just see the final rendered page. That's it. So again, we only have to handle the states where everything is fully loaded. Let's see what the code looks like. So same thing here, we have the routes, we have our state which has a current route. This I'm going to get into a little bit later. But here, again, same thing as before, nothing special going on. We have for each of our different routes, we render our component, but instead of lazy loading using that mechanism that we were using before, we have this lazy helper that comes from React. This lazy helper, we give it an async function where we import our code and we return it in a default structure that it expects, and then we can simply render this component. We don't have to check whether this component is undefined because that's not the case anymore. Our new state just has all the async stuff fully there. Let's look into the schedule component to see what that does. Ignore this part for now. We have our active tab. We have all of the 3 different tabs that you can use to switch between. And then we have the day schedule. So this is, again, this is the same component. Previously, this was combined in one component. Now I have split it out. So this day schedule component takes the active tab as a property, and it uses that to fetch the schedule. Now, once again, in our previous version, this sessions variable would be an array of sessions or null. Here, it's just an array of sessions. Again, we don't have to handle the undefined or the loading state. The data is just there. Same thing here. We just fetch our speakers, and here we have an array of speakers. Here we map over the sessions. We have a button for each of them, and we just find the speaker for this current session, and we render them here. No undefined, no loading state. The session details page, you can see the same thing. We get the session with the current session ID. And this time when we are fetching the speaker, we don't need to check here as well that if the session is undefined, just give me a null, because the session data is just there. We also have this use async action hook, same thing as before. This works the exact same way. This use async data hooks is the only one that's really different right now, and I'm going to dig into why or how exactly. And coming down here, we're also lazy loading the attendee rating and the speaker review components. So now you might be wondering that, okay, we have eliminated the intermediate states from one state to another, and we can stay on the current state while the next one is loading. But those intermediate states were kind of important. They told the user that something is happening, that the app is actually responsive. Right now, if I just click go back, it's just stuck there, and then the app loads in the new state. This is a lot more visible when we click on this page, because I clicked, we're waiting, and then it pops in. So just removing the intermediate states doesn't solve the problem, because now it feels like the app is unresponsive. But again, go back to the try-catch idea. The point of try-catch is not that we don't have to handle errors anymore. It means that we choose where to handle errors and at what level. So let's see what that looks like. I'm going to go back to this app, and I'm going to uncomment these two lines here. So this is a component called Suspense, which we import from React, and we give it a fallback. Let's save this and see what happens now. When we go back, oh, there we go, a loading indicator. When we click go back, loading indicator again, and then we see the page. When we click on day 3, once again, loading indicator, and then we see the data. So Suspense tells React that, hey, if this piece of UI or anything in this section of the UI is ever not unresolved, or it's in progress, or if there's something asynchronous going on that's not complete yet, show this fallback. And then once all the asynchronous stuff is ready, then render the contents here. That's what we tell. Again, it's like catch. If any error is thrown in these expressions, handle it right here. That's the idea behind this. But maybe as soon as we click here, the entire UI disappearing is not the greatest user experience in itself. So let's go to the schedule component. And we have our day schedule component here, which fetches the data for the current tab and shows all the buttons. We're going to wrap it in Suspense as well, save it, and now when we go back, when we click on a different tab, this is the only part that goes to fallback. So instead of removing the entire page and showing the top level state, we simply do it for this part of the UI, because that's the only part that's unresolved. We can even see this if I refresh. We show the top loading placeholder when we are lazy loading the component or the page. But once we are done, we don't need to. We can show the tabs here because that component doesn't fetch any data. This is the component that fetches data, and we have a suspense around it, so we can show just that fallback. Let's go back here and also wrap our session details page with its own boundary. So I'm going to move it here because for some reason Prettier moved it after the ternary. So now the session details page, or the component, is also wrapped with its own suspense. Which means when I click here, I see loading session details. Which means that something within the session details page or this component is not ready yet. And we are only going to show everything when everything is ready. Let's log in. This time we log in as a speaker. We're going to click on here. We're going to wait for everything to load. This is going to take slightly longer, but then we see the entire page. Now, again, we can keep nesting these suspense fallbacks as far back as we need to, or as far down as we need to. So for example, maybe on this page, we don't want to block the entire page. Maybe we want to show the session and the speaker data as soon as we have it, and we can wait for the feedback widget and its data to load independently. So once again, we go to the session details page. This is where we show the bookmark, the session, and the speaker data. We're going to leave it as it is. And then we're going to wrap our feedback components with suspense. And the fallback is going to be loading feedback widget. So we go back here, go back, select a different page, go to this component. So now we show this data as soon as it's there. but then this entire thing gets its own fallback because that's the piece of UI that has its own suspense boundary. So that's pretty cool. This means that we get to choose where we put the loading placeholders depending on the UI layout and not the data, which is especially nice for UI designers because they tend to think more in terms of UI anyways, and they don't really have a concept of loading data and showing placeholders based on specific pieces of data. But there's one slight problem here. Let's click on this button and see what happens. When I click on it, the entire page goes to fallback. Click on it again, entire page goes to fallback, and then we see the state. This is not great. So maybe when we don't have any data on the page, it's okay to show a loading placeholder. But when we already have some data here, maybe we don't want to go to fallback. Maybe we want to keep showing this data for as long as we can. Luckily, this has a pretty simple fix. But before that, let's dig into the magic that makes it all work in the first place. The use async data hook, which is a custom hook that I have here. In the classic version, in the last demo, this was using a use effect to fetch data, which is how you might be already doing it, and how most libraries are doing this. But here, we are doing something special. The first thing is that we call this async function inside a use memo, which gives us the promise. So it's going to start fetching that data immediately, and it's going to give us the promise of that data. Then we use something called use that comes from React. I know the naming is kind of weird. React has kind of been a little all over with their naming, but this function is called use. And think of it as an await inside an async await module. So we give it a promise of a string or a promise of t. And on the other side, we get t. We don't get t or undefined, we just get the value. So this is kind of how it works. Now, if you want to know how the exact mechanism of how use works, again, we can chat after this talk. It's really interesting and kind of crazy and hacky, but it works. And then when we want to refetch, I have a simple piece of state here that I can toggle, and this memo depends on it. So every time this piece of state changes, we call the async function again, we get a new promise, and we use this promise here. Using this promise is what triggers suspense. And of course, on the initial load, when we start fetching this data, we get the promise, we use it here, it's going to show our fallback. But how do we avoid that happening? It's pretty simple. We wrap it in start transition that also comes from React. Let's see what happens now. I go back. So I'm going to come back here and see that the initial render is all the same. I click on this, loading session details, and then loading feedback widget. Cool. But now when I come back here, I click on this, we don't go back to fallback anymore. We just keep our current state, and when the new state is ready, we transition to it. Again, this is what was happening already before we had any suspense boundaries. Adding suspense is what added the fallbacks or the loading states. And by using these transitions, we opt back out of that behavior and we keep the current state for as long as we can. So set fetching here is really what triggered our memo to give us a new promise, and it's what caused suspense. So you can think of start transition kind of like this. If anything inside this transition causes a suspense fallback to show up, this transition will tell React that, hey, don't show the fallback. Keep the current state under the suspense boundary and only switch to the new state once it's ready. There's actually a lot of little details that go into start transition. It's a whole separate talk on how this one function works, so I'll reserve that for later. But one more thing that I can show that transitions are really useful for is back here. So when we go from day 1 to day 2, once again, we show a placeholder here instead of keeping the current state. Let's see if we can fix that. Here in our schedule component, you can see that when the tab changes, we just set this active tab to something else. We can wrap that within a transition like this. And this time, instead of getting start transition from React, we're using this use transition hook. Now, start transition works the exact same way. But in this hook format, we get this additional piece of state, which is a Boolean. This is going to be true for as long as this transition is happening in the background. So if we save this and see what happens now, I click on day 3. We hold the current state. We are still on the day 3 page. We don't show the fallback, and only when day 2 is ready, we switch to it. And in the meanwhile, we can see that we have an indication that something is happening by this entire thing getting transparent, or the opacity is reduced. Here you can see that if navigating is true, we set the opacity to 50%, and if not, it's on full. So this is how we can use transitions to opt out of suspense, to keep the current state, and to do all the asynchronous stuff in the background while, and when everything settles in its place, that's when we switch to the new state. All right, that was a lot of exposition on new features. Let's recap what the suspense model gives us. We get to represent async states without being forced to represent intermediate states for every piece of data. We get automatic cleanup of things we don't need anymore, which is especially helpful for race conditions. So if I click from day 2 and immediately click to day 3, I'm never going to see the results for day 2. We get conversion of control. So something higher up can decide what happens when something async happens under it. Again, same concept as try catch. We get view scoped fallbacks instead of data scoped, which is again especially helpful for UI design, because you design what UI needs to fully be there instead of what data needs to be there. And we get transitions to do a bunch of things in the background, like revalidate some data, or refetch some data, or fetch the next piece of data, the next page, and only show the UI once it's done, instead of going to fallbacks. That said, this model does come with some challenges that we have to keep in mind. It's render blocking. I'm going to explain all of these with actually yet another demo. But the four here are render blocking, promise caching, eager execution, and component scope. Most of those don't make any sense, so let's hop into yet another demo. The layout is still a little messed up, but this is a much simpler demo. Here, if I refresh, we have the loading phrase counter, and then we have a loading state right here for loading phrase, and we have a button here that's a simple counter. When I click on it, it's going to increment to a new number, and this is going to fetch some phrase for whatever number is currently active. So if I go to 4 is the number of times I'm lucky. Probably not true, but that's probably a lot more true. So for each number, we get a phrase. The code for this is also pretty simple. So here I'm not using the custom hook that I've made. It's because the problems that Suspense has, React kind of deals with those problems by forcing you to use a framework for data fetching. And it hopes that the framework is going to address some of those problems using its own APIs. So here, I'm not using a library or a framework. I'm just using the straight up React APIs that we have available, so that we can see some of these problems that we can get into. So we have a state for our counter. We have a use memo to get the message. So this function gets the hello world string that we have, and we are rendering that in our h1. So of course we have our use memo that returns a promise, and then we have the use function that awaits the promise and gives us the string inside. Then we have this get phrase function that takes in a number, so 0, 1, 2, 3, and fetches the phrase that we want to show. And here we are just keeping the promise around. We're not using it right here. Instead, we pass this promise into this component. So you can see this component accepts a promise as a prop instead of just a string. This component is the one that uses it, so it extracts the value from inside the promise, and then it shows it in a p tag. Once again, click on it, and we load loading phrase, and we see the message here. So obviously this message component is the one that uses the promise, and that's why we have it wrapped with suspense, which means every time we click the button, this message component throws or suspense, and we show the fallback. But initially we have the loading phrase counter. It's because we can It's because we're using this promise here, which means this function, this component can also be async, and then we have a wrapper component to give this entire component its own fallback. Now, the first thing that you might notice is we are passing a promise as a prop. Why is that the case? Well, it's because if we use this data right here, so if we do something like this, and let's say that I'm going to render this right here, I'm going to comment this out, and I'm going to do that. So now, instead of passing a promise, let's say that I'm passing just a string into our component. If I go back, I refresh. As soon as I click this button, we don't show that suspense anymore. We show the overall suspense that our entire component is wrapped with, instead of just that message or just that p tag. It's because these using promises is scoped by component. So this entire component has to suspend, which means this entire component needs to be wrapped with a suspense boundary. So if we want to avoid that, we have to pass promises directly into components that are going to be using it. But then you might ask that why don't we do this fetch directly inside this component? That's also true. If we can grab this right out of here, we can put this in here, and we just need to pass the count as the prop instead of the promise. Yes, we can do that as well. But let's see what's happening here really quickly. I'm going to open the console, and if I refresh, you're going to see that we are fetching hello. We're only fetching hello, and then at some point we're fetching the phrase for our number here. Let me increase the delay to make it a little more obvious. I'm going to make this 3 seconds and make this 2 seconds. So refresh, you see fetching hello, we stay there for a while, and then we fetch phrase for 0, only after we have already fetched this message, this hello world message. And that's the case because this use function stops the execution of the component right there if the promise is unresolved. We can see this by simply moving the order of these two fetches. Now we have the phrase fetching first, and then the hello fetching, and this is the only one that we use on. So now if I refresh, hey, there we go. We are fetching both at the same time. Again, this is because use immediately stops the execution of the component. So if I have in this order, I'm not even going to get to this line of code until this fully resolves. So we have a very accidental waterfall happening here. So this is why, in one way, we are incentivized to fetch higher up in our component tree so that we can efficiently parallelize them. But then in another way, we are also incentivized to use our promises as low as possible so that we can add these suspense fallbacks. We have more options to add them essentially, and we don't need additional wrappers to add these suspense fallbacks. So these are the problems that I mentioned about blocking and about component scope. And the next one is eager execution. Let's say that in this promise, I somehow want to manipulate it or transform this value before it gets rendered. But of course, I can do it just right here. So I can go to uppercase right here. But this is after it's already been used, after it's already entered the React lifecycle. So down here, now it's fully uppercase. Let me reduce this back so that we don't have long delays anymore. But what if we want to do it while it's still a promise, or maybe we want to do it higher up so that the components down the tree don't know about it? Well, it's a little awkward because we have to do dot then, we get the text, and then we t dot uppercase, like that. So we can still do it, but let's see what happens. Click on it. It doesn't happen here. Is it because usually React throws an error right here? It's because this promise is created within this lifecycle of React, and React really doesn't like that. The other way we can see this is something that's been hidden from both of these demos, is that if you can see both of these functions are wrapped with a special cache helper. This cache helper basically what it does is if you call getPhrase twice in a very short time increment, it's going to return you the same promise. It's not going to make that fetch twice. Let's see what happens if you remove that. Remove it, and I refresh. There we go. So I refresh, and we are in an infinite loop. Oops. React and infinite loops is a crazy duo. So this is what happens if you don't cache the promises yourselves outside of the React render lifecycle. It's that your React is going to try to run the component. The component is going to create a promise. That promise is going to suspend, which means the component stops execution. And once the promise resolves, React is going to try to render the component again, which will create the promise again, which will suspend again. All right. So yeah, these are some of the problems or pitfalls that you can get into when you're using Suspense. Oh, slight correction. These are some of the problems that you can get into when you're using Suspense with React. Once again, I cannot thank React enough for coming up with this way of managing asynchronous data and asynchronous states. It took them a very long time to get all the details correct. But they also recognize the problems with their model, these pitfalls. And they rely on frameworks like Next.js, like Remix, to address these issues. Fortunately, React is not the only framework that has Suspense. Because there's another framework, one that I help work on now since last 2 months ago. It's called SolidJS. And SolidJS has kind of a habit of taking all the best ideas of React and supercharging them by removing most, if not all, of their limitations. At the cost of having to use signals instead of plain values. And that's no different with Suspense. The async model in Solid actually works very similar to what I've shown in React, except that the pitfalls of the React model are not there anymore. Instead, you get a non-blocking model where creating or fetching async doesn't block rendering. You get reactive caching because reactive systems are basically caches on their own, so you don't need an additional caching mechanism. You get lazy execution, which means you can pass async data from a component to another without having to accept promises. So you're actually just passing regular data. And finally, Solid is expression scope instead of component scope. Let's see what that looks like. So now this is the same demo as I just showed in React. We have loading phrase counter, we have our hello world, we have our counter, and we have the phrase. You can click on the button many times, and then we load the phrase. It's the exact same thing. Let me move this here. Now, this demo, the code is probably going to look very familiar because, again, Solid takes a lot of inspiration from React. We create a signal, which is our version of useState. We have the count and set count. Then we use this primitive called create async, which is kind of like the combination of use and use memo in React. So you give it an async function. So here get hello returns a promise of string, and hello. I don't have TypeScript here. This is a JSX file. It's not TypeScript, so I don't have full TypeScript support. But hello here is also a signal of string. Same thing here. Create async. We call this getPhrase function with this and we read the count variable here. So signals don't return the actual value. They return functions, and you have to call the function to get the current value of that signal or of that state. We have an effect here that logs the current value of the phrase, so you can see it here. Every time we have a new value, we see it in the log. Then we have our h1, where we read the hello signal. Again, we have to call it to get the current state. We have our button that when we click, we increment the current counter. And then we have our message. I'm going to remove the uppercase for now. So you can see that we just pass the value of the phrase signal here as text or as the prop here. And down here, we just render props.text. So we don't have to pass promises around. And what you're going to see when I refresh is that we fetch both at the same time. This is the default behavior. Even if I go back and change the order of these two, that doesn't matter because we are still going to fetch both at the same time. This is because this create async never blocks rendering. We are going to continue rendering this everything as far as we can. You can even see when I refresh, we are rendering the message component way before we have the text. And after we have rendered it, we never re-render it. Solid never re-renders components. It does the minimum amount of work required to update the UI, which in this case is just updating the DOM element. The other thing that you will see here is we don't need to pass promises. We just have the suspense fallback around this message component. It was the same earlier, but we needed to pass a promise for that. And we still see the suspense here. It doesn't trigger the suspense of the entire component. In fact, this entire component doesn't even need to be wrapped with suspense. The only thing that we need to wrap with suspense is the piece of UI that reads from the async signals. We can even put a suspense just around this H1, like that. And we can say loading message. And when we go back, refresh, we see the loading message instead of the entire thing, or instead of loading phrase counter. Because it's only this H1, it's only this expression that triggers the suspense, not the entire component. And finally, because we have lazy execution, we can take this piece of data and just say to uppercase. Again, I don't have TypeScript, so it doesn't autocomplete, but that's all I need to do if I want to transform the value at any point. So now it's transformed. We don't need to do a promise.then, and we don't even need to handle the undefined case because the data is just there. All right, so yeah, I might be a little biased here, but again, I think Solid does a much better job at taking the same ideas that React kind of pioneered, but removing the pitfalls from them by being a really efficient reactive system. The only thing is that you're not dealing with plain values and objects anymore. You have all the states in your component or in your application are hidden inside signals, and you have to call those signals as functions to retrieve the correct value. That was the demo that I just showed. So, synchronous state is as simple. Asynchronous state, I guess, used to be complex, and with these new patterns that React and Solid and I hope other frameworks, Vue I believe also has suspense, but it's in experimental mode. But I'm hoping that with these new patterns, we have made the handling of asynchronous state and asynchronous operations much easier and much simpler, so we can have a better time building applications, building highly dynamic applications, and our users don't have to sit through 20 different loading states to see what's going on. That's all I have. Thank you very much.